Thank you all for coming. So yeah, this is making the big data ecosystem work together with obviously a focus on Python, although a lot of the big data ecosystem is actually written in Java. So we'll see how that can add some extra challenges, including my slides. Click. There we go. So yeah, my name is Holden. My preferred pronouns are she or her. And I'm actually a PMC member on Spark, which is like a committer but with tenure, because they can't really kick me out anymore, which is lovely. It's kind of a shitty version of tenure, though, because it doesn't really guarantee a paycheck. So it's like this not very useful tenure. If you're interested in learning more about how open source development works, one of the things which I've started doing is code review live streams. And you can follow me on Twitch or YouTube. And what I do is, as a committer, one of the things that you're responsible for doing is reviewing code changes. And so I broadcast those so people can see the process and maybe be slightly less scared of contributing to open source, or at least encourage more people to contribute to open source. And I'm also a co-author of some books. They're not too important. In addition to who I am professionally, I'm trans, queer, Canadian, and part of the leather community. And this isn't particularly directly related to big data, right? There is no secret Canadian JVM debugger that we've been hiding from you. I wish there was, honestly. Like, god damn. But I think it's important to remember that we all come from different places, but we all face a lot of the same challenges, especially with writing software. And we should be nice to each other and work together rather than being, not so nice to each other. So please be nice to your coworkers and remember that they may come from different backgrounds than yourself. So I'm hoping you're all nice people. It's a Python conference. That's a pretty good sign. I'm actually really curious. How many people in the audience don't know Python? It's totally okay if you don't know Python. One person. Yay. Thank you. Welcome to the community. We're really excited to have you here. And the examples will be in Python, but they will hopefully be easy to understand. How many people are interested in distributed systems? Thank God. Okay, how many people really don't care about distributed systems? Okay. This is focused on distributed systems, but even if you don't care about distributed systems, I think we can learn some interesting things about how tools can work together in general and best practices. We can essentially learn from the mistakes that the distributed systems ecosystem has made. So we're going to talk about how big data tools play together. Then we'll talk about how big data tools play together between Java, the JVM, and Python, and also other languages. And I'm going to look at a lot of Apache projects and one non-Apache project. And we'll do a bit of a deep dive into PySpark because I have the most experience with that. And I'll try and get you to buy my book and subscribe to my YouTube channel because why not? There will be a lot of pictures of cats. That is the one thing I can guarantee. So how do big data tools play together in general? So maybe you've got your data in a SQL system, and now you want to do some machine learning on it. Normally, the answer is take your data, save it somewhere, load it into the machine learning system, and have fun. And this is really frustrating because this pattern is repeated over and over again with all of the different tools in the Hadoop ecosystem. It's pretty much save your data into a file format and have the other system read this file back in and pick it up. That's not too slow on local files, but when you have distributed file systems and like terabytes of data, this starts to get really, really sad. And then if you add multiple languages into the mix, this can get even more complicated. Sometimes you can use Kafka to like share your data between multiple people. It's better than files, but that's like a real low bar, right? That's like being better than MapReduce. We kind of all got to get there, and if we don't, there's some questions. And we also end up having meta tools. We have to have tools on top of our tools to get them to play together. I have to have a tool that will say, hey, what's up? I finished my ETL job. Now it's time to kick off my machine learning job. And it's just like, why do I have a piece of software to run my other piece of software to run? Oh, god damn it, right? And that's fine, but sometimes people write shell scripts to do this, and then that's not so fine. Okay, so there's a bunch of things about this that are sad. It's hard to test. Writing to disk is slow. Writing to distributed disk is twice as slow. And Kafka is comparatively fast, but not so bad. And does anyone use something like S3 or Google object store, or IBM's object store. Yeah, okay, a lot of people. So you'll find this nice property where they look a lot like HDFS, and a bunch of tools kind of work with them. But occasionally, you'll get exciting race conditions because they're not actually HDFS, and they don't make the same guarantees. So not only is our thing slow, we occasionally get race conditions from files that are partially written and then consumed, missing a chunk. And it turns out that as flexible as our parsers may be, that is not a good time, even for JSON records. And so part of this was solved to some small degree inside of Spark. And it's not perfect, and we'll talk about a lot of its shortcomings shortly. But Spark looked at the big data ecosystem and said, well, what about if I just put most of the tools people want together into one package? That sounds like a solution. Now, admittedly, that's a solution that quickly leads to a lot of other problems, but it's a good start. So for example, I can have my SQL data and my machine learning living together in the same system, and this is kind of cool. I can do my ETL and machine learning without writing it out to disk, saving it, reading it back inside of another system. The downside is now my machine learning job can crash my ETL job, but that's fine. That's fine. Everything's okay. The other downside of this is that there's 2 machine learning systems inside of Spark, 2 streaming systems inside of Spark, and there's 1 graph system which doesn't work. And there's another graph system which I'm told might work, but we forgot to put it inside of Spark. So, oops. But the nice thing to note is that we can also access this in multiple languages, and that's really going to be what we focus on mostly today. So how do people get Python and other non-JVM languages to work with these largely JVM-based tools? It's a combination of pickling. We're all familiar to some degree maybe with pickling. If not, it's not too bad. Other times they use strings. Some people use JSON. Someone looked at those 3 things and said, you know what this needs? Enterprise. And now they use XML for data interchange between processes on the same computer. I'm going to argue that was probably not an improvement. And occasionally other random custom one-off solutions would be the polite approach. Anyways, and then they communicate these over Unix pipes, sockets, writing things out to local files, and occasionally, if they thought slightly further ahead, but not all the way, memory mapped files. And so, yeah. Essentially, because we can't really share memory very easily, and we have a very different understanding of the world in Python and the JVM, we end up using these kind of old school methods of sharing data between our processes. Some other people looked at that mess and went, oh God, hell no, that was a terrible idea, I'm not doing that. And they said, you know what the solution to a poorly implemented tool is I'm going to rewrite it, but this time I'm going to do it purely in Python. And that was a great idea until they realized that they had to talk to the other data systems. And the other data systems weren't written in Python. And so we have some really cool pure systems insofar as Python is pure. It's largely actually C code under the hood. But they just don't integrate well. And so that's sad too. So, okay, how does this actually apply in Python and Spark? Is anyone actually here a Spark user? Yay, friends! And also, I'm really sorry. Yeah, this is my job, and I'll admit I haven't done the best job. Actually, maybe I can distract you. My shoes light up. See? That makes I'll do it on this side of the stage, too. Very important, and totally compensates for the fact that we've been copying things over Unix pipes for years. So it's actually pretty mature. Occasionally we forget to implement parts of Spark in it, but that's okay. We normally fix it when someone tells us. And this part is the one which really sucks. It has some serious performance hurdles sort of inherent in our design. And let's look at this. Oh, are there any JavaScript users for big data in the house? Don't be shy. Any? One! Come talk to me afterwards. We did something really crazy with JavaScript. It's amazing. Anyways, okay. So, yes, of course, this is a big data talk. I must include word count. I'm sorry. This is not the last you're going to see of word count if you ever go to a big data talk. But essentially what we can see here is this looks kind of like Python code. Admittedly, someone had an interesting idea of what a Python API looked like, but there's Lambda expressions inside of here, and those Lambda expressions are totally Python code, and that's awesome. But to make it work, we used these 3 things, or 4 things. 1, 2, 3, 4, counting. Oh, I was going to replace this with something, but I didn't remember to change it to an image. But so pickles, sockets, pipes, and JSON. And let's look at that. So has anyone used Py4j? You and I should be friends. I want you to debug some code. So Py4j is this really cool library for making Python talk to the JVM. Its performance is terrible, but it's really cool, and we just use it on the driver program. And that's the program which sort of coordinates and asks for the work to happen. It doesn't do most of the work. So the fact that we use this kind of slow thing on the driver program is okay, because it's not doing nearly as much work. This part is the part where it gets sad. We looked at pickling and decided to write our own custom library. That was a good plan. And we now have a version of Cloud Pickle, pickling for the cloud. Okay, that goes over better, with cloud customers, or actually worse. And then we also decided that we didn't want to just pickle our data. We also wanted to use JSON as well, because I was tired of being able to understand what was happening. And so we have this concept called schemas, where we have this idea of what types a data frame contains, and we decided to represent that as JSON data. And we do a bunch of copying the data back and forth, and that's kind of sad. So in addition to illustrating that I do not have an illustrator to work with, this shows you our very high-quality architecture diagram. We can see on the workers we have a Java process, and this Java process is the one receiving all of the data, and in fact actually receiving serialized Lambda expressions that it has no idea what the hell they are, and it often doesn't understand the data, and copying it into Python and just being like, yo, you got this, right? And Python's like, yeah. Cool. And if you want to use Flink, it looks pretty much the same, except replace everything with a different thing, because it's European. Yay! It's like the sockets. Sorry, that joke goes over much better in America. Anyways, I actually haven't tried that one in America. So how does this impact PySpark? The double serialization cost is the big one. We have to take the data, serialize it into the JVM, and then that's cool, but our work is actually going to be done in Python, so we have to take that data again and reserialize it into a format that Python can understand. And Java is well-renowned for succeeding at bit operations, which is largely what pickling in the JVM looks like. That was mild sarcasm. So it's really slow. There's a bunch of other issues. They're not as important. Has anyone got a PySpark error message? Raise your hand. Keep your hand up if you understood it. Uh-huh. Yeah, okay, that's what I thought. And this has this other property of, because we have essentially this Frankenstein monster walking down, when it explodes, we're just like, I see bits everywhere, and I don't know which bodies they're from. It's very sad. This monster is it's a very nice monster when it works. It gives me data, but when it doesn't, it gives me sadness. So Spark looked at all of this and said, you know what? I'm just going to do my computation in the JVM. I can just take Python things and translate them into Java. How hard could that be? Well, for some things, it actually works out pretty well, right? Like, I can see adding 2 numbers and be like, yeah, I can add some numbers in Java. But if I try and call something like a library, maybe spacey, not work so good. There is no spacey in Java. I checked. And so, yes, be wary of distributed systems bringing claims of usability. So Spark data frames are more like SQL tables. They're not actual data frames. I'm sorry for anyone that was expecting real data frames. And what they do is essentially they say, you can't have your Lambda expressions, but I'll be really fast if you write it in this DSL. And that's, I mean, it's not the end of the world, because the DSL isn't like really terrible, but most of us probably like Python because of its libraries or things we want to do with Python. And if all I can do is use this DSL in Python, it's not really Python. And word count. So it actually did say, OK, yeah, so that's probably true. We'll let people use their Lambda expression. But when they use their Lambda expression, the performance will be kind of bad. But when we do things with like this nice, fancy DSL, I'll give them really good performance. And that's like a partial solution to this problem. And I have a graph that shows you that it runs faster. This graph may or may not apply to your code. So if you have like old Spark code and you rewrite it into this DSL, it might run a little bit faster. Ooh. Yeah, that part at the bottom, the part where it says bad idea. Yeah, that's on all of them. So yeah, so there's this PR that I came up with, and I was like, you know what? Let's use Jython. Yeah, okay, well, yeah, that was a bad idea. But it actually, it got to a good point, right? Like, our problem isn't actually that Python is slow, right? It's that we're spending all of this time copying this data around. And I have this word count on GitHub data. I don't know why I chose GitHub, but probably because it gave me the benchmark I was looking for, where it was like, yes, this will perform almost as good as native code. And so the yellow and the green go together, and that makes them happy. But it really sucks, right? I can't use any of my cool libraries. It's Jython, it's Python 2.7. I want to be with the cool kids, writing Python 3, using like Spacey, totally. The solution to this is to not get away from copying data, but just make that part not suck. We're still going to have to copy data from the JVM into Python, but we're not going to use custom implementations of pickling in Java. We can use this fancy thing called Arrow, which is coming really soon. Arrow has some other cool things that we'll talk about too. And so it is the future, probably. It made it into the release, Spark 2.3. You can accelerate your UDFs. You can have really nice, fast Lambda expressions in Spark. And in fact, I have another graph that implies you could get a 242 times speed up. This is a lie. But it's a very nice sounding lie. And that's what software is built on. Yeah. That being said, you will probably, not a guarantee, right? Like, you will probably see a real speed up. If you see a 200 times speed up, please email me so I can include you in the next version of this slide as a real world use case. But most likely you'll see like, 1.5x or something like that. And we can use, 1.5 is good. I mean, I'll admit it's not 200, but that's pretty close. Okay, so one of the things is this is powered by Apache Arrow, and essentially Apache Arrow is not just for making Java and Python talk together, it's for making all kinds of things talk together. And it's pretty awesome. We can use the Arrow libraries to read in Parquet files directly if we don't want to touch the JVM. That being said, like, it's a false sense of security. Don't worry, it's actually C++ code. Actually, mostly C code with macros, oh god. Or we can use something on top of the JVM to provide us our data, get like Spark, and then we can use Arrow to copy it into one of these fine things. And emphasis on the ish with the TensorFlow part. There's some undocumented features that should be fixed. And actually, there's a few undocumented features here too, and we'll talk about those exciting opportunities for improvement, as it says in my performance review shortly. So we all know that Python is really good for numeric computation. And that is why we're going to add the number 1 to every element in a series, because I don't trust Java to do that. In fact, I might actually get exceptions in Java, but that's a story for another time. So we can use this decorator, and we can still have our nice Python Lambda functions. I mean, here I gave it a name because it's slightly easier than using this decorator on a Lambda. There's another thing that I can do, but it's kind of ugly. And when I do this in Spark, it will go ahead and it will use arrow instead of our really ancient hacks. And this is kind of awesome. And I can actually use it to get a local data frame-like view on a per partition basis of my data. That's somewhat esoteric, but essentially Spark splits up our data onto a whole bunch of computers. And if we ask it to group it together in a certain way, we'll end up with the data about each key being together inside of one partition. And then if I do this type of grouped map operation, it will let me take a look at all of the data for that key on a pandas data frame, and I can use my pandas operations finally for big data. Yay! Pandas for big data. I thought that was going to go, oh yeah, that's coming up later. I thought that was going to go over a lot more excitingly. I am clearly very bad at judging this. Okay, so that's a lot of Spark stuff. How do other systems do this? So Hadoop streaming, which is not a streaming system despite its name, was like, yo, I like Unix pipes. And it's kind of sad, but it turns out that MapReduce was pretty bad anyways, so we just didn't notice. So that was cool. Yay, overhead. Kafka gave us two options. One of them was a re-implementation where I can talk to Kafka in pure Python. Turns out, slow. Another one where I can talk to Kafka in almost pure Python, with C code actually doing all of the work. Not that slow. But occasionally lags in features. And by occasionally lags in features, what I mean is has never achieved feature parity. And the final option of we could use Kafka streams and call it with the terrible things we did before, but that's pretty terrible. So all of our options are bad here too. Yay! Okay. And now we come to Dask. Dask actually gives us data frames that look like pandas data frames, and they often quack like pandas data frames, but occasionally they do make a different sound, and that's unfortunate and leads to a runtime exception. But that's okay. And if all you want is a distributed data frame, this is really weird to say as a Spark committer, you probably actually want Dask. Spark is cool and all, but Dask did a really much better job on distributed data frames. The only thing is, the places where they didn't is talking to the rest of the big data ecosystem. So if all you need is a distributed data frame, and your data is magically distributed on a bunch of computers in H5 files or something, you are good to go. If you want to talk to something that came out of Scoop or MapReduce, or Spark, or something else. VNext, yeah, or V1+2. I don't know. Whatever. It doesn't work for that. But that's cool. And there's another system, and it doesn't work outside of Google just yet. But we're totally going to fix it. For real, there's code, and it's public. It's just not in a release. And not only do we recreate all of the same mistakes that Spark did, we looked at that and said, you know what Spark is missing is Docker. Because Docker is really, really cool. And what I want to do is I want to Dockerize everything. And so, yeah, we got a lot of Docker going on. It is a party. And as much as I joke about this actually addresses a really interesting point in the big data ecosystem. Most Hadoop cluster administrators are lovely people who have never heard of Python. And when I go to them and I'm like, hey, what's up? I need a newer version of pandas. They're like, what now? Holden. And I'm like, no, pandas is actually a thing, not just something I say when I'm drunk. And then after a bit of back and forth, they'll upgrade it for me once, but they'll forget to do it on some of the machines. And then I'm kind of sad because my code just doesn't work reliably. And Docker gives us a really nice way of being these are my dependencies. Please ship them to all of my workers for me. And this is a really important problem to solve because we didn't solve it yet anywhere else. And if you want to see the design document where we went, hey, let's recreate Spark's errors, but different, you can check it out there. And it is going to be a bit different. And there's this random collab branch, which if you want to click on will take you to some random person's GitHub, where they've been like hacking together, making Go, Python, Java, run on top of Beam with Flink. And it's just like, ooh. Also, hilarious to debug. Because you can pretty much picture the Spark story, but with an extra thing in the middle. Because everything can be solved with another layer of abstraction. But as much as I joke about this, once these lines turn from orange to black, like it's going to be really exciting. Because then we can actually use... Actually, are there any Go users in the house by chance? I have 3 slides for 3 people. That's a good ratio. And we can actually use languages which haven't traditionally been part of the big data ecosystem. Even Python's like been sort of riding along in the sidecar, but like maybe not riding the motorbike. Okay. And so for those 3 Go developers, yeah, we can count words. Word count. Oh yeah. The main point of this is to illustrate that we can do pretty much the same thing in languages besides Python. I probably actually, in retrospect, should have picked R as the second demo language. But the Go functionality was added like 2 weeks ago, so I was really excited about that. But you can also just like rewrite this into R in your head, and it's pretty much the same thing. So why are these things starting to work now? Like, why is this starting to get better? Part of it is, like, Arrow exists. There's better formats. But honestly, there's always been better formats than, like, JSON for data interchange, right? Like, we've always had better options. They've just gotten a lot better. The other one is, I think, the main driving factor is that JVM developers are now faced with the reality that they have to call Python code to be able to raise their next series of funding in San Francisco. And as such, they're like, well, I need this to work well enough to show to an investor. And that's not very well, but it is better than it worked before. And so we've seen a lot of improvements because people want to use deep learning libraries from Java. And we can pretty much take that stuff which is possibly useful and use it for actually useful things besides deep learning too. And the other part is like Arrow is awesome. And there's this other really cool thing. I don't know if anyone else is excited by multi-language pipelines. People excited for? Okay, there's like 4 people who are really excited for multi-language pipelines. And multi-language pipelines are super, super cool, mostly because I have to write in multiple languages anyways, so everyone else should too. But it's more like Python has some really, really great libraries, but so does R, right? And sometimes most of what I want to do is really well suited to Python, but there's like this tiny bit which would be so much simpler to do in R, right? Or vice versa. And it would be so much cooler if that could just be one pipeline rather than like doing some weird copying between programs, right? And it technically sort of works today. And we're going to look at how it technically sort of works with a demo project, which you can all definitely go and check out on GitHub and like laugh at the delightful code. And we'll talk about also how it's going to go from like kind of painful to use to less painful to use, because that part is probably more exciting. That's when you'll go from like looking at a demo project on GitHub and being like, cool, I never want to do that, to like, cool, I'm going to use that in my pipeline. So this is where I introduce sparkling ML. We have this tradition in the Spark land of naming things sparkling X. So there's like sparkling water from the H2O company, and sparkling ML, I didn't have a lot of good ideas. And so there's this panda wearing a hat, because we're going to use it to get access to pandas, machine learning, and do cool things. And so there's a panda wearing a hat. Okay, well, I guess when I have to explain my logo, that's probably not a great sign. It was from Fiverr. And the idea behind sparkling ML is essentially, I work with a lot of Java people. For better or worse, it is my life. And I make no comments because I know that they can search on YouTube and find talks. You know, there is a camera. Yeah, okay, there's the camera. And so that's cool. But sometimes when I'm working with the Java people, they have an NLP problem, or they have another problem where like the Java solutions are just kind of like, oof, they're really rough. But the Python solutions are really awesome, and I want them to be able to use those Python solutions inside of their code. And we can also use it in reverse. If there's like some really cool Java functionality you want to get at inside of Spark, you can do it. You pretty much just ignore underscore. And you're like, what? No, that's fine. It's totally normal to type sc._jvm.com.like blah, 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 .new. And yes, you pretend this is normal, and you hope to God your cluster never gets upgraded. The TLDR of this ignore the underscores part is like, we can do this today, but like, don't do it in a job you plan on keeping, because then you're going to have to maintain that code. And that is going to suck. That should be future someone else's problem. What? Oh.
After it's harder to fire you.
Yes, job security, it's true. It can be harder to... I never want to be that person, though. Right, that is how you become the COBOL programmer maintaining like this giant payroll system or something that's vitally important to the company, but oh dear God, no one wants to open and see how many monsters live inside. I'm going to focus on exposing Python functionality to Java because people talk less about that. But if you want to see it the other way around, you can look inside of Sparkling ML and see examples of both. I exposed the Lucene analyzers from Java into Python. And the Lucene analyzers are almost always worse than the Spacey analyzers. But you can see how it's done if you had Java code that you wanted to call. The main thing that we have to do is we have to write like this really ugly startup file with a bunch of global variables inside of it and a class which implements a Java trait, which is, Java interface. I spend too much time with the Scala people. So essentially, we write this wonderful thing called Python registration provider, which is a sign that, yes, I have indeed once worked at an enterprise shop. And we say, I expose this package, and this is what I implement. And that's fine, right? Then the Java people know who to call and like kind of what to expect back from us. And then we provide this like register function, which takes in a streaming Spark context. I don't remember why I wanted it to be streaming. Whatever. A Java Spark session, which is somehow distinct. Don't worry about it. The name of the function they want, and all of the parameters from Java serialized with pickling, of course. Yay! Pickling. And then we go ahead and we look this up in a kind of ugly table. And then okay, let's skip the part which is sad. If anyone wants to read the sad part, the slides will be posted later. And then in the Java side, we essentially have an interface, or if you're working in Scala, a trait, which matches that without the implementation detail. And we call this piece inside of Spark to construct our Python driver program. Even if we're not using Python, we just call that same entry point. We do have to pretend that we're inside of package org Apache Spark, but that's totally normal. And if you work in Spark for long enough, you'll find out that you pretty much end up having to do that at one point or another because we've made a lot of really bad decisions about what things should be private. And it's really boring. You can look at it if you want. But let's skip the boilerplate and go back to counting words. Yes. Okay, so one of the things which faced me early in my life as a developer was I did this really cool pipeline for building recommendation systems for my glorious employer at the time. And then they came to me and they were like, hey, Holden, that's great. We saw like your recommendations have increased whatever metric by 0.000y%, and that means X like millions of dollars. And I'm like, yeah, I feel conflicted about my life. And then they were like, we want you to take this to other markets, and we really want you to take this to the Japanese market. I'm like, that's cool. I'll just like change the name of my pipeline, make a copy of it, because like copying code, totally fine for maintenance. And I'll just tokenize that. Wait, oh dear. I'll just tokenize. Oh, fuck. And so it turns out not every language does a great job with tokenizing by spaces. And being the North American kid that I was, I didn't realize that until my first job. And so that went poorly. But now, if I had the same problem again, I could just call spacey rather than doing the hack that we did, which was like every 2 characters is a token. Whatever. I had no idea how to judge the results. I seriously plugged them into Google Translate and was like, this looks okay. Whatever. This is why you need a real internationalization team. But anyways, so now we can use cool functions that support multiple languages. Cool. I don't know if you have the problem of multiple languages in Europe. Of course not. Oh, but yes, this is the point. And now we can call it from the JVM, right? If I've made some cool things and I'm working with a team that like is maybe the production data team, and they're like, this has to be in Java because that's what our pipelines are, I can be like, no, it's cool. You can just call my Python code. Let me show you how. Please ignore startup.py. It is totally normal. And if you want, you can send them my email, and I'll be like, yes, very normal. And so we can go ahead and we can say, like, hey, this is the parameter that I have like for the language. These are my input and output columns. Like, please go ahead and run this tokenization for me. And they do this, right, because you're a very persuasive personality, right? You go to the engineering team and you're like, this is going to be so much better than rewriting spacey in Java. And it is, because rewriting spacey in Java is impossible. We could go back to that Jython thing to try and make it go fast, but then it turns out that Jython and spacey are not friends. They had a fight. But it's just not very fast. But we could think back to the earlier part of the presentation where I talked about arrow. And instead of tokenizing individual elements, I can tokenize a series of elements that is serialized with arrow. And then arrow will be super fast, and this will probably, oh, sorry, I should clarify, winking, run at 200 times faster, right? We saw that in the slides. Yeah? No. Okay, this does not run 200 times faster. It does run faster, though. Alternatively, you might be like, Holden, no, I don't care about my Java friends. Like, they can go and re-implement spacey by themselves. I just want to use this really fast. And we can just do the same thing that we did before. We use our pandas UDF decorator, and everything's happy. Here are the references. That's the GitHub project that I was talking about, where you can go and see all of this terrible code to make it work. It is hilarious. I strongly recommend it. There is the expression patches welcome, and they are, but I don't know why you bother. And if you're interested in learning more about the space generally, Apache Arrow has a pretty good site. One of my former coworkers has a really cool blog post. And we're approaching the most important slide. If anyone's really interested in Spark, there are a large number of Spark books. I am a co-author of a few of them. But it was only in my latest Spark book, High Performance Spark, where I realized you could negotiate royalties with publishers. Like, for real, they'll pay you different amounts just for asking. And so I get a lot more money on this book, and I think it is a great book. Yeah. It is not overly relevant, but that should not stop you from buying it with your corporate credit card. Okay. If you want to come see me in any of these places, these are places that I will be in the future. I sincerely hope that this place is actually on a beach. I do not know if Jay on the Beach is really on a beach or not. I will be upset if it is not. And I'll be back for PyData London to talk about Spark auto-tuning with my co-author. And there's not like a super lot of time left based on the little timer thing. I think there's like time for maybe one question. And then if anyone wants to find me, you can probably pick me out of the crowd here. My shoes light up. And yes, so come find me later with questions, unless we want to do like one really quick one right now. Does anyone have like a really quick question? Okay. Oh, there is one really quick question.
Amazing talk, thank you. What do you think about Ray? It also uses Arrow, and it's kind of like similar to Dask. What should we choose now? Like,
that is a great question. I think Ray is really interesting. I love research projects. Fuck. I guess that answered it. The TLDR is, I think it's really cool, but I don't think it's a thing that I would run in production today. That being said, like, I think it's a thing that will either be abandoned in a year or something that I want to run in a year. And I don't know which way it's going to go. Probably depends on how long it takes the grad students to finish their theses. Oh, I forgot to tell everyone about Boo. I'm sorry. This is Boo. She's my co-presenter, and she travels with me everywhere. Her name is Boo. Okay. Thank you. Sorry.